Eccoci qua, ben ritrovati.
Welcome back.
Tempo di affrontare la seconda sfida.
We now start our second challenge, which is security, which is fundamental. I would kindly ask my head of unit to join me here on stage. He is in charge of the high-res hydrogen technologies and resilient energy system unit at the Sustainable Energy Center of FBK. He coordinates and works at projects covering the entire supply chain of hydrogen, from basic research to applied research, in cooperation with local businesses and European partners. We have Giuseppe Signoretta, Fabio Bolzoni, and Cavaliere Claudio participating in this panel. Thank you, Ilaria. Good afternoon, sorry, good afternoon. Welcome back from the coffee break. I would like to briefly introduce our session on safety, not security, but safety. And the three panelists are Giuseppe Signoretta, who is an aerospace engineer with experience as an asthma nuclear inspector, and he is currently working as a technical manager at Bureau Veritas. Then we have Fabio Bolzoni, who is a professor at the Politecnico in Milan in materials science and technology. He teaches various engineering and research courses on the durability of concrete structures and corrosion of materials. He is chair of the Study Center Corrosion and Protection of Metallic Materials of the Italian Metallurgy Association. And then we have Claudio Cavaliere from the Fire Brigade Service and Civil Protection Service of the Autonomous Province of Trento. Safety is of paramount importance within the framework of hydrogen, because it is explosive, because of its fire ignition features, and this, of course, has to be taken into account, because we need to restylish the various safety aspects in relation to this to hydrogen. I have a first question to Engineer Signoretta from Bureau Veritas. There are two different certifications. There is a compulsory one, which is required by law, and then there is also a voluntary certification, which is typical of non-harmonized approaches. I would like to know about the value added of certification organizations. So in addition to compulsory certification, what about the result and outcome coming and output of voluntary approaches? Well, thank you very much. Thank you for your question. Thank you for your kind invitation. When speaking about voluntary certifications, we can compare and contrast it to the compulsory certification framework. And when we say voluntary, this means that it is a trust-based approach which aims at going into further depth in terms of quality of what is certified. If we then consider all this in relation to hydrogen, we know and understand that safety is of paramount importance. There are a number of areas related to hydrogen which are not covered by norms, not yet. So when the production of hydrogen takes place, we need to have parameters in place which are applicable to production and also certification. For instance, certification of origin of energy used to produce and also storage systems. What about the role of voluntary certification? What is this role? Well, voluntary certification establishes parameters, and it also identifies possible issues and criticalities, which is very helpful for those who then draft the rules, regulators. As a certification organization, we started with a voluntary certification, working with the fire brigade at national level, with the H2T group, and draft together the national standards. So the value added is there when it comes to voluntary certifications. It is fundamental to establish parameters. A number of elements are already covered by the law. Others need to be covered. And we also need acceptability criteria, which need to be defined when talking about standards and norms, because they are the elements that attach a quantity to things. Let's think of leakage of hydrogen. You said it is a highly explosive element, so you need to quantify leakage, or you need to establish the compulsory distance of hydrogen from a road, from a building, and so on and so forth. All this is something which meets the needs of producers. Producers ask voluntary certification organizations to cover that aspect if the law per se does not rule about that specific aspect. And of course, a voluntary certification can be more restrictive in the end than the future standard, national standard. So this is what a voluntary certification does for hydrogen for the time being. Thank you. Thank you very much. Indeed, your work paves the way for the subsequent national standards. So thank you. Of course, it is not only individual components or their integrations or devices that have to be taken into account. We also need to consider the materials these components are made of and their reaction with hydrogen. And here comes the question to Professor Bolzoni about the studies performed at Trento University about possible things that happen when hydrogen touches and comes in contact with specific materials. What can we do to reduce risks in that respect? Good afternoon. I would like to thank the Bruno Kessler Foundation for inviting us here. And I would like to thank the Autonomous Province of Trento that has entrusted us with the task of performing the study that you mentioned. First and foremost, I would like to frame this topic within a more specific context. There is a rather bulky document, number 25134, of the European regulation body that served as a basis And we took from there as a reference the percentage of hydrogen being 20%. Elsewhere, 10% is mentioned. But anyway, we took the reference from the standardization body. And then pressures should be considered in relation to storage or transport. Things change in the two scenarios. In scientific literature, you find more about transport. That is explained by the fact that, on the one hand, the history of interaction between hydrogen and metals entails that the more sensitive materials are those that display a higher resistance. And that is one thing. On the other hand, you need to consider that you can think in terms of additional scenarios in relation to pressure, because the calorific value is different than that of natural gas. So that has to be considered again. And we have more data about transport. As for steel, there are other elements to take into account. The strain that metals are subjected to is lower than their resistance. If you're a mechanical engineer, you know that the safety coefficient there is very high. Pressure is not that high. The strain on the material is not very high, and steels used are low resistance steels. So putting everything together, we can state that there are limited problems when it comes to the material if we stick to the scenario that I have just depicted. The study of phenomena about the fragilization of hydrogen date back to studies about oil and gas corrosion, where you have H2S, which is a promoter of the entry of atomic hydrogen into metal, because it is only atomic hydrogen that can enter the metal, which means that the gaseous molecule has to separate, and then polymers are a totally different thing, and we'll briefly talk about it. But anyway, in oil and gas, corrosion is more severe as a problem compared to what we can think about for gaseous hydrogen. When interacting with those who have to pick the materials for these applications, we see that sometimes they refer to the standards which are applied to oil and gas, but they are more severe, more stringent, as I said, because corrosion is different, is on a different level for oil and gas. And then it is also true that we lack a specific regulation on the qualification of materials at European level for usage with hydrogen. But there are other regulations outside Europe. Certainly in the United States, studied a lot, and in Japan, extensive publications were made. I also found a European project called Naturali from 2008-9 on transport, and that contains a lot of information. Welding, too, has been extensively studied. So if we stick to the scenario I depicted earlier on, I would say that there are no major problems. On the other hand, as I said in the morning, there is also an experience about shorter pipelines because production there is already 100 million tons per year for those applications. And we are still talking about materials. The weak part, the weakness is in general the tenacity of the material, and that goes especially for gaseous hydrogen. and also fatigue strength, so strength and fatigue strength. With the autonomous province of Trento, we investigated the specific situation where there are special conditions where strain varies over the course of time and is transformed into fatigue. If that is the case, then you need to be careful, because fatigue is something worse in the interaction with hydrogen when compared to a static situation. Then polymeric materials. We focused especially on high-density polyethylene, which in the Trentino system, based on the samples, I would say, that we could analyze, and we received them from Novaretti, is limited to 1% of the local sites that we investigated, and still makes out 99%. High-density polyethylene has been extensively tested with natural gas for more than 30 years now. So from this viewpoint, the problem is a different one. It's not a question pertaining to the embrittlement of the material, but also the fact that gaseous hydrogen can go through the structure of polyethylene. It is elastomers, rubbers are more permeable in this respect. So we should focus more on tightness when it comes to polymers than permeability per se. That is one element of attention that we need to have. And if we still consider as a reference the standard I mentioned earlier on by CERN, and also if we refer to the Margograz organization, for instance, for gas producers, mention is made that for pressures up to a number of bars, there are no issues with polyethylene, but you should pay attention with elastomers because they could entail problems of permeability even at low pressures. And then if you have a very high pressure, and it is the case of transport, suggestion is made, or rather recommendation is made, to make tests and experiments, because we still lack knowledge, not so much experience has been made in that specific domain. So I initially introduced the scenario, and there we do not have special problems for steel and polyethylene. We need to be careful when it comes to unwelded joints that need to be further investigated. This is not the case for Trentino, but elsewhere in Europe and in the rest of Italy, we still have cast iron as a material in gas pipelines. And there you have special joints on cast iron for those pipelines with some sort of hemp material which is added to the joint, and that should be further investigated. In any case, tests need to be continued. Polymers especially do change very much, also based on their components and the additives that they contained. Thank you very much.
Well, I would like to listen to you for another hour as you spoke about materials. Very interesting. And the other requirement is the fact of purifying gas. Yes, impurities have been studies. There are impurities which worsen, and some impurities which can improve, like oxygen. So we have to check that point. Now, the floor to Engineer Claudio Cavaliere of the Fire Police. Well, I think that this is a question that everybody does. I know that there is a technical rule saying that there is a specific code to be respected in terms of safety. So there is a whole list of requirements. I'd like to have a short explanation based on your experience, how you can tackle the issue of compressors and stockers, and whether you know that there are specific applications of this rule. Now, I convey to you the greetings of the Provincial Command of Trento, and I'd like to invite you for, thank you for inviting me here to FBK. Now, in terms of anti-fire regulations, we have two rules. One of 2018, which relates to self-traction, that is all activities related to hydrogen. This is something which is developing fast because there is a push by the PNNR. I think that 27 and 28 projects were approved, mainly in the north of Italy, with reference to distribution plants. But the problem is that they will not be fully dedicated to hydrogen. There will be some fueling areas where other classical fuels will be distributed. And also in Trentino, we have already examined two plants for the distribution of hydrogen. The other regulation that you mentioned refers to number 2, 2023, and it relates to the construction and management of hydrogen, because the distribution areas, which also have 2 or 3 tons of hydrogen, at a certain point, you have to bring it to distribution areas. So there is this regulation dating back to 23, which is different from the regulation of 2018. So this new regulation relates to risk assessment by the designer. So there are some guidelines related to Decree 2015 of our Code of Fire Prevention, which is our Bible, and the analysis that the designer has to implement in order to assess explosive atmospheres which can be present in the area, and then assessment and evaluation of the detection and alarm systems, which had to be highly sensitive. And in terms of pressure, this new regulation evaluates different types of pressure, because in 5 years research has changed. And so the designer can evaluate also different levels of pressure. And then the risk evaluation depends also on research and innovation, which makes a contribution. For example, in the regulation of 2023, there is a reference to a specific rule which makes reference to the ISO norm 22734, which is a fundamental reference because the ISO norms, which is an international standard, are updated more as compared to anti-fire regulations. So the ISO norm is continuously updated. So there is a continuous evolution. Well, I'd like to add one point. The voluntary certification enabled us to certify valves for a couple of our customers who work with hydrogen. Now, when we submitted this work to the specific committee, well, this now is being transformed into an ISO norm. And this is a clear example of what the colleague from the fire brigade said. So an example of how a voluntary certification deriving from the need of a specific customer, where there were no rules related to connections, because in that case we examined the connection between the various elements. Well, that brought to a regulation which is now applied to all gas infrastructure. So thanks to working tables, and it is very important to participate in these discussion groups, that has led to a national rule. So the voluntary standard has turned into a piece of law, and it is then included in the anti-fire regulations and others. So that's an extra added value. So very interesting. I didn't know this aspect. I was convinced that the voluntary rule was related to a situation of quality, but it is really a stimulus for the rules, for the regulations. Thank you. Thank you so much for your answers. Now, I see that we have completed our time. I don't know if there are questions from the floor. Thank you. For Engineer Cavaliere. Well, I work at Sol, technical gas company, hydrogen service stations, production and storage. Well, a market which is growing is the one which the law defines mobile systems. Well, in 3 different regions, we already faced the problem. And we are a big company, and we, in our interest, prefer to have a connection with the local fire brigade offices. So I'd like to know from your experience, and with reference to the province of Trento, whether there is a guideline which we could look at. Sorry for this rather sensitive question. Well, when I said the 2 projects were approved in Trento, clearly we do not look at the whole picture, but we look at activities above a certain level of danger. And with reference to hydrogen, there is no specific activity, and above a certain threshold, we look at these projects. So below that threshold, which is called Activity 1, we are not compelled to have our assessment, so we're not required to have an assessment. But for reasons of safety, you say you would like to have a connection with the provincial fire brigade. Well, we use as a reference the national decree. I know that that may mean higher costs, but until we have a national regulation, every region has their own regulations, and we in Trento are organized in this way. Well, some of the offices asked for the physical barriers, and others simply said no. Yeah, that was very smart. Thank you. If there are no other questions, we close the session. Many thanks to the panelists, and I hope it was useful for everybody. Thank you.